Warm welcome to my lecturer and my fellow friends. My name is Devan Rajendran. My matrix number is 25DDT19F1184. Today I am going to present my problem-based task set A. This is a topology with 4 routers, 3 switch and 3 printer and 12 PC. There are 6 parts in our objective. Part 1 examine the network requirements. Part 2 design a hierarchical IP addressing scheme. Part 3 assign and configure IP addresses on the network devices. Part 4 verify connectivity on directly connected networks. Part 5 configure EIGRP routing protocol on each router, and part 6 about verify EIGRP routing. The required resources will be packet tracer 8.0.0.2 and the packet tracer file from lab 4.1. This is a packet tracer file and also the PDF file 4.1. For the part 1, examine the network requirements. Answer all the questions below with an elaborate explanation. For the first question will be the how many subnets are needed. So here from this topology we can see that there will be 1, 2, 3 and 4, 5, 6. So there will be 3 one network subnets and 3 LAN network subnets. So there will be totally 6 subnets. So for the next question, what is the maximum number of IP addresses that are needed for a single subnet? And for this question, here we can see that the R2 LAN, R3 LAN, R4 LAN will be requiring 120 host IP addresses, and the one links they are not specified any host IP addresses. But we can also see that in the topology for the one we will be only using the 2 IP addresses, and since there are 120 IP addresses are required for the LAN network, the maximum number of IP addresses that are needed for single subnet is 120. How many IP addresses are needed for each of the LANs? For the third question, we can see that for the each LAN there are 120 host IP addresses are required. But in the question, this are asking for IP addresses, so we will be including our network IP address and also broadcast IP address. So that will be 122 IP addresses are needed for each of the line. And the next question is how many IP addresses are needed for all of the connections between routers. All of the connections between routers. So that will be 2 for the first connection, 2 for the second, and 2 for the third. So there will be a total of 6 connections. And the final question, what is the total number of IP addresses that are needed? So there are 3 LAN networks with each of them required for 120 host IP addresses, and also 3 WAN links that are required of 6 IP addresses. Totally there will be 166 IP addresses. For the part 2, design a hierarchical IP addressing scheme. Subnet 192.168.8.0/22 as per requirement. Calculate and assign the subnets to the network. Show your calculation for each of the subnets. The subnets are assigned to the networks to allow for route summarization on each of the routers. For the part 2, I have prepared an Excel file to calculate the each subnets. And so for the first subnet will be 0 until 5. The first will be R1 to R21. Second will be R2 line. Third will be R1 to R31. Fourth R3 line. Fifth will be R1 to R41. And the last will be R4 line. The network given for us will be 192.168.0/22, and we are required to separate the network into 6 IP addresses. As per the question before, they have already mentioned what is the number of IP addresses that are needed for single subnet. That will be 120. So we'll be submitting into 120 for all the 6 subnets. The first will be 192.168 and 0, and here we need to add 1 since there is 8. The 8 will be the 192.168.8.0, and the rest will be again 0. According to the question above, we are required to assign 120 IP addresses for a single subnet. So the most suitable will be the 126, which includes the 120. That means the before will be the network address. Let me highlight it. Okay, here we can see the first the 8 byte, then another 8. Total will be 16 together with the another one, so 24, and the last one will be 25. So the network is 25/25, and the starting IP address will be 192.168.8.0 since all of the back will be the 0. So for the broadcast address, I will be copy paste the entire numbers. The broadcast address will be calculated from the non-highlighted numbers, which means the numbers behind the highlighted will be added into 0. So how to calculate the broadcast address? First, we need to add all the hosts in here: 64, 32, 16, 8, 4, 2, and 1, and that will be 127. So the broadcast IP address will be the 127, 192.168.8.127. The subnet mask will be same for all the subnets /25. And here we can identify the first IP address 192.168.8.1/25, and the last will be 192.168.8.126. So let's continue with the R2 line. And here we need to add 1 since the previous numbers are already used. So the next will be the binary number will be added in front, and the rest will be the 0. Now for the second LAN R2, we will be also using the /25 and the 120 host IP addresses. So the same will be highlighted. And for the network, it will start from 192.168.8.128/25. The 128 comes from here. Since there are 1 here, it will get the 128 IP address. So for the broadcast, we will be also adding the 1 after the highlighted places. And since all the 8 bytes are 1, the total IP address will be 256. And after minusing 1, we will be getting 255. That will be the broadcast IP address. And the first and last IP addresses. Let's continue with R1 to R31. And all the previous numbers are now 1, so we need to add the 1 in front, and the rest will be 0. So here we will be also using the 120 host IP addresses. And the network will be 192.168.8 plus 1, that will be 9. So for the broadcast IP address, we will be adding the 1 after the highlighted places. And it goes the first and last IP address. So the next is R3 LAN 192.168 and 8. And for the next number, we will be adding 1 in the front. For all the subnets, we will be using the only 120 hosts. So the same one will be highlighted. 192.168.9.128/25. We got the 128 from here. And for the broadcast, I will be adding the 1 after all the highlighted numbers. And so that will be 192.168.9.254, sorry, 255/25, and the first and last IP address. And so next is the fifth subnet. And here will be the previous numbers are all in the 1, so we'll be adding the 1 in front. And it makes the network to 8 plus 2, that will be 10. The rest will be remaining 0. So the network address here will be 192.168.10.0/25. Since all the numbers in the last digit is 0. And for the broadcast address, 192.168.10.127/25, and the first and last IP address. And now the last one, R4 LAN. And now we can see the last network is 192.168.10.128/25. And for the broadcast IP address will be the last IP address in the network. So that will be the addressing table. Now we are ready to configure the devices. The next part will be assign and configure IP addresses on the network devices. Assign and configure IP addresses on the R1 router. For this part, I will be using the lab 4.1, and here we can see the assign and configure the first valid host address in R1 to R21 subnet on 000 interface. Enable configure T. And the first required will be S000 interface. No short command. In the IP address, 192.168.8.1. So all the networks and subnetmasks will be using the same prefix /25. That will be the subnetmask 255.255.255.128, and for the wildcard mask there will be 000 at 127. And for the next one, assign and configure valid first address in the R1 to R31 network. So that will be the S001 interface and R1 to R31. IP address 192.168.9.1. And the next one will be R1 to R4 first IP address and S010 interface. So that's the command for R1. Now with the R2 router, and there are only two connections with R2, R3 and R4, which will be the route connection to the R1 and the one LAN networks. Interface S000. Second valid host IP address, that will be 8.2. And no shortcoming. And here we are required to configure the LAN networks also. So the connected one LAN network will be F00, and all three networks are connected to the same port F00. For the F00 interface, the first valid host address in R2 line. One nine two dot 192.168.8.129, and the no shut. Same goes to the R3 and R4. So that's for the R3. Now for the R4, also the same commands with different IP address. Interface S000, no shut, and the IP address 192.168.10.2 255.255.255.128, and the one connection, no shut, 192.168.10.129 255.255.128. So that's for the configurations on the routers. And the next part will be assign and configure addresses on the host devices. The second to sixth valid host IP addresses on the host A, host B, printer, host C, and host D. So the second valid will be 192.168.8.130, and it goes on. And that's for the R2. Now let's move on to the R3. R3 starts with 192.168.9.130. And for the last PC 192.168.9.134. Default gateway 192.168.9.129. Next is about the R4, starts with 192.168.10.130. R4 OST will be the last PC to assign IP address. So now we have successfully configured the IP addresses for the devices. And next, at the end of the task, your completion rate should be 91%. And here we can see the completion is 91%. Part 4, verify connectivity on directly connected networks. Now I will try to ping from PC A to PC D. So the connection is successful. And I will also try to ping from PC to printer, and it's successful. Last will be the default gateway 129. R2 line is working successfully. Now the R3, I will try to ping from PCC to PCA, and it's successful. The printer is also can be pinged, and the default gateway 129 can ping also. Last is from host B to host D. Successful. And the printer also successful. And the default gateway. By completing that, we can see that connectivity on the directly connected networks is configured. Okay, and so for the next part 5, configure AIGRP routing on each router, starting with router R1, R2, R3 and R4 with the autonomous number 10, and also we need to configure the route for all the directly connected networks. Let's start with the R2. The command will be router EIGRP 10, and for the network, to show IP route. And here we can see there are two networks connected directly. And we will start configuring with the network 192.168.8.0. And the wildcard, okay, I guess we don't need the wildcard mask for now. Okay, so that's the configuration for the R2 via JRP and R3. As we can see in the R3, there is the connection from 192.168.9.0 and also 192.168.9.128. So we will be configuring only the 192.168.9.0 network. And same goes to the R3 also, sorry, R4. So the network will be 192.168.10.0 for the R4. And next will be the R1. So in the R1 we can see there is three connections, 192.168.8.0, 9.0 and also the 10.0. Okay, we can see now there is three connections, three adjacencies are connected from the R2, R3 and also R4. So by configuring the EIGRP routing protocol, we can see our completion should be 100%. And the next will be part 6, verify EIGRP routing. So to verify EIGRP routing, we can use various commands. Show IP route, and in show IP route we can see there's two connections connected in the R2, and next will be show IP protocols. So in show IP protocol we can see the EIGRP10 connected and the one network we configured before, and with the gateway 192.168.1. Show IP EIGRP topology. So in topology we can see there are four connections, 192.168.8.0, 192.168.8.128, that both will be the directly connected, and the 9.0 with the 10.0. And the next comment will be EIGRP neighbors. So we can see there is one connection for the neighbor. The 8.1 will be the R1 router. So next will be R3. In the show IP route we can see there is two EIGRP connections, 8.0 and 10.0. And in the show IP protocol we can see the EIGRP10, the routing for network, and the gateway 9.1, which will be the R1 interface. For the neighbor, we can also see the 9.1 interface, which will be the R1 interface. And finally, the topology. There is also 4 connections, 2 for the directly connected and the 2 for the from the serial interface 000. Same goes to the R4. Show IP route with 2 networks and show IP protocol with 1 routing network, 1 gateway and also edge RP10. The next will be show IP edge RP, topology and also the neighbor. So here we can see there's 2 connections for directly connected and also 2 for the networks coming from the serial 000 interface. And the neighbor we can see only one, which will be the R1 interface. The next will be R1. So IP route. And here in the R1 we can see there is 6 EIGRP connections, 1, 2, 3, 4, 5 and 6. So each of them are, and next will be show IP protocols. And in the show IP protocol we can see the EIGRP10 and the automatic address summarization for the 3 networks 8.0, 9.0 and also the 10.0. Next we can see the routing for networks, also the same networks. Finally we can see the gateways of the 3 routers S000 interfaces. In the topology we can see there is 1, 2, 3, 4, 5, 6 and 7, 8, 9 interfaces. And next we can see the EIGRP neighbors. So for the neighbors we can see there will be 3, R2, R3 and R4. And here we can see in the R2 the network 192.168.9.128 and 192.168.10.128 is summarized into the 9.0 and 10.0. The subnet mask is also changed to /24 instead of /25. And same goes to the R3. The 192.168.8.128 is summarized, and also the 192.168.10.128 is also summarized. The subnet mask should be 125, but now after the summarization we can only see the /24. In the last router R4 we can also see 8.128 and 9.128 is also summarized into the /24 IP addresses. And finally, to verify EIGRP routing connection, we can also ping from PC to PC in the other networks. In this case, I will be pinging from R2 host B to the printer in host 3. 9.132. And here we can ping from LAN to LAN. And I will be also pinging from R3 host D to R4 host D. So the connection is succeeded. And that will be the end of my problem based task set A. Thank you for watching.